Thank you, Duncan. And I'm going to try and start off really slowly, a bit nervous, and I feel very vulnerable being a Kiwi coming into this landscape in such a stressful time. It would be fair to say we have small pockets of our country in a similar state, and unfortunately one of the situations that they've just had snow for the second time in North Canterbury for the second time in 3 weeks, which is quite a rough time frame when you've got no feed and you've had a dry winter. So there's small parts of our country that have similar interactions, and we rely very heavily on a break and winter conditions to actually get out of jail quite regularly. But that's also why we have winter cropping as well, because we know we don't grow a lot in winter, so we cycle back onto crops to move grass production forward to a spring lambing phase. So that's a real difference in a cold environment that we work on. So today what I'm going to cover is speed dating plants, and I think Rob dodded me in on this a little bit because it is a bit of a gig coming in after lunch. You're starting to get a bit sleepy, and I can honestly tell you I cannot tell you a lot about some of the plants that you use on your properties. I've been travelling to Australia since 1998. It was my first experience. Within the first 6 to 8 years of travelling to Australia, I clipped up 2.5 years on my passport at the cost of my family, but the experience was amazing. It did mean I saw Australia dry out after the sort of slightly wetter phases in the 1996. I thought I was coming to talk about salinity, tall wheatgrass. It was actually quite a big deal getting prepped as a young person coming to Australia. I was thinking, what the hell is tall wheatgrass? By the time I arrived, it was actually just turning into a strategic shelter in individual paddocks, is where it sort of got to with some of your climates, and the salinity story had sort of disappeared. So it is interesting how things cycle and change. It took me till 2010 to see some serious grass, including in landscapes like Simpson down on the coast. I couldn't quite work out how this was supposed to be rolling green pastures, because actually that was the sort of landscape I came into. I always came in on your dry seasons, and I never came in your good seasons. So that was the experience I sort of generated through the 2000s. What I wanted to touch base on is a topic that is a little bit less and a little bit higher level than some of the absolute brilliant detail you've been given this morning. And I want to just sort of make plants real. You know, they have a life, they have interactions, and they interact with each other and your businesses. And so I want to keep it really high because I can't go into the detail that's been shared with you this morning. So I'd ask you to bear with me, and let's go dating some plants. So the first thing I'm going to look at is some grassland ecological principles, and I think that's a really important point because in persistent pasture systems, you are fighting ecology to keep what you want there, because ecology is going to kick in at some point of time based on all the discussions we had before lunch. Going to talk about our grasses, the legumes, some of the herbs, and then we're going to touch on a diverse pasture project we've got running at our beef unit in Canterbury, which some of you have visited through your tours with the PPS group. Just coming back to Jason's presentation, we're talking about acidity, and I'm going to do a wee brief here once I've covered the ecological part of what we actually discussed before lunch, my spin on it. But what I want you to see here is this, a diagram I started creating when I had a moment. And the biggest thing about this diagram is you think about the pH ranges you were discussing with Jason this morning. Look where most of the roots sit on many of these plants. I think that's 20 centimetres. You know, we were discussing a relatively narrow band of soil when we're discussing 20 centimetres deep. But a vast amount of our productive rooting structure sits inside that zone. So when we're trying to talk about persistent perennial grasslands, we are talking about creating environments where root structures can be deeper, or placing plants where root structures can be deeper in the soil so they can have resilience in tough times. So it's quite important to realise just how many of our productive plants harvest from the top 20 centimetres of our soil landscape. And when you realise that, it actually brings absolute life to everything Jason described to us earlier. It's a really important part of the soil profile. But if you want to discuss deep-rooted perennials, you've actually got to respect what's below 20 centimetres if you want to achieve it. So it's a pretty interesting set of characteristics there, and I was thinking about his work and I was thinking, well, that's pretty shallow to be discussing pH, but the reality is it fits perfectly with this diagram with just how much of total rooting mass sits in that zone. Really what I want to look at here is just some of the principles of grasslands ecology. And look, your paddocks are not native grasslands. In some parts of Australia, you're running, in the broad acre, you are running naturalised grasslands. And the reality is they're often found in steady state. And in steady state, there's some really strong principles of what the environment, the pressures of wild animals or livestock are on those. And the biggest single principle is it's called a grassland for a reason. It will become a grassland no matter what you start your process with. If it's loose and it's left unmanaged for 20 years, it will become a grassland. Because ecology will always drive it back to that species as a dominant species in your landscape all around the world. And so what you tend to find is with time, no matter what you start the process of mixing seeds together, you will end up with a grass landscape that will be about 65 to 75% of ground cover will end up being grass, particularly if you pick the right grasses for your landscape. And if you don't, it will still be grass because they will be weed grasses, naturalised grasses, grasses that are not desirable necessarily, but they'll end up being grasses. And in some of your country, that will include sedges and onionweed. So they will fill that niche depending on your situation. And then what happens in that grasslands, I've just quoted you 65 to 75% grass. That leaves a gap. Okay, that gap is filled by the next most successful style of plants. Typically, it's dicots, and typically they're described as forbs, so they are your weed species or broadleaf species. Flowering natives they can be, but the reality is that they are broadleaf plants. And not always do they come second in that ordering, but they'll fit at about 18 to 22% of your grassland botanical composition over time. This is steady state. This is what nature will drive you to. And then there's a third order, and typically they will be legumes. And they'll be legumes at a very low level, and many of them will be micro-legumes, medics, naturalised legumes. And this is undeveloped natural landscapes, very annual, very short season. Now you can mix these orders up and you can run a more legume-based system and you'll see the proportion of legume rise in that pastoral landscape. And if you get it right, your forbs will be at a lower level. Typically, in many of your landscapes, the forbs will be weeds. So one of the things I hope you're starting to get a picture for is if you don't work hard to try and maintain management and plant relationships, there is a natural order that will occur. And it'll keep going to that order in a really predictable way based on your climatic conditions and other resources in your landscape. So when you start working about the details about what your favourite plants, what your favourite mixes are, this is a starting point because this will be the end point and it's actually predictable. So this is where I'm going to take a breath at the end of this slide and do a hot take on what I saw before lunch and how it relates to the plant type story. But basically what we're trying to do as agronomists and farmers is create mixes that are artificially capture desired species presence for productivity, quality, or animal performance for as long as possible before ecological steady state kicks in. And that's our day job. That's the art of what you all try to do with your farming experience, your favourite pastures, and your combinations of things you're putting in your farm businesses. What you're trying to do is manipulate that landscape enough to keep them there for as long as possible to maximise your economic return on that investment. However, it is going to be something different when it's stable and when it's finished. So what you're creating every day in your day job is, relatively speaking, artificial. And so understanding all the levers to pull to maintain it for as long as possible is what this group has actually been built on, apart from your community, which is an amazing part of this group, but you're trying to find perennial pasture systems for your landscape, and by that definition alone, you're trying to keep them as what you've sown for as long as possible before actually nature takes over. And this is where everything we've just been discussing before lunch fits perfectly into what your relationship with these plants are going to end up being. And my hot take on pre-lunch, I needed to get behind here to bring it up because I couldn't remember these things off my heart. But Jason, it was a really, I've seen this, I was so thankful that he was here to share that with you. I saw it 2 years ago in southern New South Wales. It was, for me, it was a light bulb moment. I come from New Zealand. The biggest single difference between New Zealand and Australia is we have no farms that are further than 100 kilometres from a limeworks. We are a young country. Yes, we've imported vast amounts of phosphate to build our productivity, but it would be very naive for a New Zealander to think that is the only way we build our country. We have lime deposits because we're young. We're not an eroded country. We're a very, very young landscape. So limestone is quite a common occurrence, and we've been liming our country for 150 years almost. So the reality is that's something we've got that I feel very privileged that we have. It's not that easy for yourselves. I mean, I know the distances you have to get material sometimes to incorporate, and around the world that is a big deal for all acidic landscapes. So the part that is meaningful with our plants is when you change pH, you change how the pasture behaves, which you must change your management of that pasture once you invest. Otherwise, you'll warp the balance. And I can only remember the picture of the very strong phalaris where the lime had been improved, phalaris became dominant, and it smothered out everything else in the mixture. So if you change something and you improve, nothing in your business actually changes unless you change other things in your business to eat it. Because another quote that came out later was, it's not about how much dry matter you grow, it's about how much dry matter you eat. So one thing leads to another, and it becomes a really important, then you react to it to actually convert to that economic outcome. And I can't leave that conversation without saying the target's 5.8, not 5.5. 7. Yeah, no, I'm going to. It's a lower level one regarding the weather forecasting. It reflects my issue as I'm Alistair, but everyone knows me as Al, so I sign off AL. Unfortunately, I don't use A capital L, which makes it look AI. And that's a bit of a problem because it scares me what AI does to my topics. When I look up something like writing a paper or creating a poem about a plant, AI does an amazing job at pulling out those things in a heartbeat. The only positive thing about that is very few people write that information to create the AI harvesting, and so I do a bit of that writing myself. So yeah, AI is harvesting our information and giving it back to us in a very fast time frame, and it's very freaky. But the part that I took away was a very simplistic part of a really impressive presentation about the complexity of the living thing that is weather. Is AI data source can create bias. I feel that's a really important thing as we head towards AI spitting out a lot more information for yourselves, is that unintentional bias being created. We do enough of it to ourselves. We create unintentional bias through individual experiences, and we actually create those biases for one-off experiences, and yet they hang with us for quite a long time frame. And yet AI, depending on what it's harvesting to regurgitate stuff to us, can create bias, and that's quite an interesting point to keep in mind. Just focus, and remember all of this is to do with our plants. And that's why I can't not touch on all these other wonderful speakers. Steve, it was just unlimited the amount of stuff that I could have pulled out of his presentation to include in mine, and I was really impressed. There's one thing I never will be able to get out of my head. I think many of you will be the same. I can never look at averages in the same light ever again. Like, seriously, that was defining what your average is about is quite an important thing moving forward. That was quite cool. But for me, there's just so many things. I think build your production system around the known knowns was something that I'll probably walk away with. There's a lot about how he presented that as an agronomist and a builder of production systems based on trying to create dry matter that fits your business, or supporting a change in business with dry matter curves that may help lambing early or lambing late. Good example. I feel his point was really poignant, and I don't want to get involved in a regional debate about lambing dates, but gosh, I mean, build a production system around the known knowns sounds very, very powerful to me. So that was probably my take home of a whole lot of things. The other one I really liked was Plan A and Plan B, and I feel that's really appropriate. They were the big ones from that one. Now, Patrick's topic wasn't really as completely linked to this topic, but one of the things I did appreciate, because I feel it's a very powerful thing in a business, is to pick your people and create teams. There is no doubt about it that some of the best businesses, you don't shoulder every thought process or every responsibility in your decision making. You surround yourselves with your team, and I feel the biggest point is they're complementary to your aims and your objectives. They're not just coming in with their ideas based on their own agendas. And I feel you have the power to work with that and create those teams, and I think that was a really well presented part of that topic. So what we're going to do is, at a very high level, discuss some plants that you know very well, and then start to think about them from a very human sort of perspective, which is not normally a common trait. And so now we're thinking about dating again, and for some of us that would be a terrifying thought. So it's really just recognising some strengths and weaknesses and acknowledging that those things have influences when you're trying to create pastures and create diversity. So, ryegrass is a pretty impressive plant. Now, look, we could talk about perennial, Italian, annual ryegrass, but we're just going to talk about perennial here. And it is not a perfect species in your world whatsoever, but I'll tell you what, it's pretty easy on average if you can get it going. And to get it going, it's easier than everything else. It's fast to first graze, it's aggressive, it kicks a lot of goals early. One of the biggest single weaknesses with ryegrass in real terms is that climate's not its friend. It's a temperate pasture species of medium to high fertility, and when people look at it from a perenniality perspective, you need to really acknowledge that. We will be able to take ryegrass a certain distance with dormancy. We would be able to take it a certain distance with that trait, but you'd give up other things. And then it's still ryegrass because it's still a medium to high fertility plant. So it doesn't travel well across all soil types and all landscapes. It's a relatively soft species. It literally evolved in fertile forest margins from the last ice age. So it had a landscape that's vastly different to where we've domesticated it today, and it's certainly a plant that its primary advantage in nearly any of your businesses is that it's easy to sow, and it grows in winter, and it grows in spring, and it's relatively easy to manage. However, from a relationship perspective, it's a highly perennial, productive grass, but it's not always the perfect partner. And the reason for this, it is very aggressive out of the ground. It's very fast to shade other plants. And so actually forming a relationship with ryegrass is not always an easy thing. So a good description would be, when you sow your mixed pasture, you go out and look at it. If you get a germ and it's coming up, you go out and look at it. And what you'll see is all your valuable legumes and all your herbs get away to a great start. You can see them, cotyledons, out of the ground nearly first. The thing about those plants is they all come from one seed and they all create a taproot. So they throw up the first 2 or 3 leaves, and then they spend more time developing their initial root structure. And in that time, ryegrass, often in the autumn, often going into colder conditions, just keeps growing up and just keeps tillering. So next thing you're dealing with is shading. And so it's just not an easy partner to keep the things that you got established from day one there by the end of your first or second grazing. So that initial grazing management of young ryegrass pastures is super, super important. And in a relationship, it is really pretty tough grass. Looking at phalaris, and obviously we've discussed a lot of things that could influence it today, including stocking rates, including pH, and grazing management within your group has been amazing and what it's brought forward in fescue phalaris management. But the thing about such a perennial species is how do you find it partners for it, especially when it gets really dense and really strong. And so this is the thing about it, from a relationship perspective, slow to establish, but perennial. Finding the ideal long-term partners for such a perennial plant can be a big deal. Because remember, the glory days of a mix are in the first 18 months, 2 years. We're not talking about that. We're talking about longevity and perenniality and how long you can keep those glory days in your pasture. So understanding the strengths and weaknesses of those grasses and where you put them together in mixes is quite a big deal. You know this, and you do this. Subterranean clover comes back every year. It doesn't have to compete with it through a summer. It doesn't have to compete with it when it's at full mass, if it's reseeding and reseeded, but it does need open ground at some point to colonise. So it's a big deal of getting that right or getting the partners right. Be interesting to see how chicory goes in that brew, but again, longevity is part of that discussion and how long it would last. Coxfit, really interesting. I've never met a grass that gets so many biasts. Like literally, I feel every person in this room will have a bias about Coxfit. I feel that's quite a big deal because when you're desperate, it probably does pretty okay. But when you're good, it's probably in a sheep job one of the last grasses you want on your farm. So how do you forge a path forward in a perennial grassland with that sort of baggage? Finding a place where it's actually a happy place for a plant that in the tough times you probably appreciate 1 or 2 paddocks, but in the good times it just brings baggage with palatability and animal performance and partnerships. So it's pretty low to medium fertility grass of pretty light soils, and you put it on some pretty tough country because of that. So when times are tough, do you think it's a highly nutritious plant? Because we just put it on some of our lower quality land as well. So we create a bias straight away. Slow to establish. It can hide in a mix for a whole season before it starts to show up if you're putting it in a mix. However, it can become dominant in a relationship. Very dominant. And Coxfit is not a friendly partner. Getting other things to live with it is not easy. And that's not just because it's a strong scavenger of everything in the top 20 centimetres, on average, mostly moisture, but the fact that in a grazing system, when you're trying to put it into a partnership with other things, everything else is nicer to eat than Coxfit. So finding that partner and that relationship is not straightforward. Sometimes with this grass, it's actually all about making economic outcomes from the short-term pastures that you might sow with it and recognise it's actually the stability of the Coxfit that's the benefit in the long term because the short-term stuff was never going to last. That's the type of grass Coxfit is in a relationship. Also with Coxfit, I do like the idea that if you really don't like it, at least you've had something in the paddock that you don't like, as to other things that just drop dead and leave a paddock full of weeds. So Coxfit has a few things in that space that I would suggest has a lot of baggage. The fescues. I've worked with these things for a very, very long time. I've always felt they're quite interesting, but they've got their own baggage as well and create bias because of that. They're deep-rooted fibrous species. We've got 2 of them in Australia that function at a high level. One's a summer active, which not often that useful in some of the lower rainfall zones, and the other is a summer dormant winter active. And that's got a really strong place in Victoria on average. The first one, dense fibrous root system, tolerant of hot summers, and that's often on deep soils, good fertility, cracking country would be a really nice example where that plant really excels. The thing about it, it's slow to get going, but it's a really good partner with other things, and I think that's an important part. Sometimes with fescues, particularly continental fescues, summer actives, they're only as good as what else is in the mixture. They're only as good for your animal performance as what else is in the mixture. And so getting that right at the start and then holding it is quite a big deal in that relationship. It's not great with other grasses because it's actually really slow. So putting in a multi-species grass mix, it's relatively expensive content to a pasture and will get dominated quite constantly by other things. So understanding its place in a broader mix can be quite important. The only way I put it in a mix personally is if I got really wet, heavy country, but highly variable paddocks. We've got really light stuff and really heavy stuff, and you might find that tall fescue works in the heavy stuff, and if I'm mixing it with other grasses, like cocksfoot as an example, it may colonise the light. So again, paddocks aren't perfect, so sometimes mixes are a solution for that opportunity. Summer dormant, strong response to autumn rains. The key really with this one, it's slow to get going, but it's a good partner once established. However, it prefers annual legume systems because it really likes a summer holiday, and having too many summer active plants in this type of grass has a really big impact on how well it recovers in the autumn. So if you continue to dry your landscape out with too many summer actives, you really delay the triggering of its recovery in that autumn break if you get an autumn break. So it's quite an important plant to also understand, again, all its partners and how you might link them together. Some people could see chicory and lucerne as some really interesting opportunities. Transition out of Mediterranean fescue in the spring into a lucerne and chicory in the autumn. But when your business is really valuing autumn break feed, you just don't want to continue to dry out your landscape before that break hits. And that's a big deal on summer dormant grass. Now, prairie grass is interesting. I think across your landscape at this moment, it would be dead literally everywhere under your grazing pressure because of stress. But in maybe the last 3 years, it would have been a really interesting species for short-term pastures, particularly in fertile conditions. What I always find about this grass is that it's actually only got moderate use in Australia, and the sheep system is probably one of the most limited for its use. It does fit a cattle system much better, and it does fit a laxer rotation a lot better. So any period of set stocking really devastates this plant. It's got broad tillers. It behaves like a short-term grass. It can last 2, 3, 4 years with reseeding included, but you tend to find it fits into a cattle system so much better than a sheep system because of that. This is a very seedy plant. It's preferred as a good companion of chicory, lucerne. They all fit together really well because, again, their rotations fit very well together. Now, hybrid ryegrass. If your perennials are only lasting 2 to 3 years, this becomes a really interesting option when it comes to ryegrass. Actually, these two are on the same slide for a reason. If you're in a bigger cattle business, the reality is prairie grass on light free draining soils has actually got the ability to be quite a useful plant. But again, hybrid ryegrass has got more flexibility in total, and it behaves more like what you expect from your general pastures. So it is actually quite a powerful option for an autumn-winter production system. It's not going to last forever, and I'm sure it's pretty much dead across your landscape at this moment on average. But the last 3 or 4 years, your results with this type of grass and productive sheep systems, lambing in April, May and June, would have been quite high. So it is a real interesting plant in those shorter term pastures. So that covers off a big chunk of that grass component. But one of the things you can't ignore is your grassland productivity, just like the pH and the discussion around lime was highlighting, is still driven by pH, phosphate, and the legumes that can come with them. Because grasses need nitrogen to have protein, and not just energy, but protein drives your animal production systems, and it's really important. As your landscape goes brown, one of your biggest drivers is finding sources of protein. And legumes are one of the major cyclists of that, and we've discussed what that does. So we're just looking at a couple here, and the white clover is obviously not a plant for this landscape to the same degree as subterranean clover, but they both have an interesting place. The key I put up there initially with white clover is be aware, it is a very free-seeding plant. We can talk about it as a perennial legume as much as we like. It's clonally propagated, you get the right leaf size in a sheep landscape and can tolerate set stocking. It just needs some moisture, and it does need not to be burnt out of your landscape. But if it sets seed, it actually can behave almost like an annual clover over the years. You'll get a lot of seed in the ground for their good years. And those good years, pretty much, are a rain in December and a rain in January. Pushes legume growth into that window, sets its seed in that moment. The baggage and the bias is we think it's a perennial legume. But I've just described to you a large seeding event. So when you look at it in another context, you put it in a year that you can get a reseeding event because momentum out of spring is good. You don't know that when you sow, by the way. But the reality is it can set a very significant amount of seed, and that one moment can last a long time. Subterranean clover goes without saying. Its best part of its relationship, it's a good partner, and it's an expert at dodging stress. It just dies. It is actually a really effective mechanism for surviving in a tough landscape. So your perenniality through annual traits is actually such an important part of perennial pastures that actually you take it for granted. But its single biggest mechanism is dying. So guess what? We don't create a bias around that, just out of interest, because that actually works in your system. So as I say, one of the things about unpackaging plants and getting to appreciate the moments that are really successful is to remember every bit of experience you create, you also create a moment of bias, which impacts the way you think about it through different seasons and different years. So somehow we do need an AI, or we do need some smart maths in our minds to realise at some point you sort of got to hold the line and recognise good years are about establishing things that are also good in bad years, not just easy and good years. So that's always a challenge. And with that, what I'm really going to show you now is a bit of work out of New Zealand, which I feel I want you to take the highest level of this on board because it's so complementary to our discussion about pH and what drives a perennial pasture. Because grasslands are only as productive as their nitrogen cycle. Because on average, grasslands don't need as much P as legumes do. So phosphate's good for developing strong roots, strong production, and giving grasslands tolerance on the edges of the season, but legumes are the ones that benefit most by highly available phosphate. So what we're looking at here is a white clover trial. Got a whole lot of detail, smack through that. It's a whole lot of detail. Let's not overthink it, but what I want to highlight is between this point here and that point there, they all look different, but they're the same grass. So too often we just talk about our grasses and put in whatever legumes we can get or what make our mixes cheap. But actually those legumes are pretty powerful and pretty meaningful. So this plot here doesn't look that flash. And that's because under this system, it is a pure stand of grass. It can happen in a dry environment. It can happen if you don't put your clovers in. It can happen if you use chemical and take your clovers out, chasing weeds. But the point is that's all the same grass. And when you look at what that looks like, that's the same grass. That's the same grass. That's the same grass. And most importantly, that's the same grass. So the only differences in these line graphs is the decision to focus on adding clover because this is grass and just nutrient fed. Then the first line above it is, I just want a cheap clover, which is this line here. The line above that is I want to capture a new clover or a good clover, bred in the 2000s from Department of Ag in Hamilton. And the line above is I want to realise that actually genetics in clover for genetic gain is actually easier than grasses because clovers cheat. If they're good and strong and produce more, they fix more nitrogen. And if they fix more nitrogen, they create more growth. And if they create more growth, they can actually, and are competitive and compete in that growth, they fix more nitrogen. So they cheat. If they're good, they'll bring more nitrogen to the trial or to the paddock or to the landscape. And that will change the way the grasses look and that will change the way the mixtures interact. Another way of looking at this, and this is pretty powerful when you look at this sort of bit of work in a steady state. This is when all the starting nutrient profile associated with establishing a pasture is gone. So you get the glory days of your first year of establishment. All new grass goes pretty well initially. So now we're in a steady state. We've only got nitrogen coming from two sources in this case. We've got the soil available nitrogen, which is actually, in this location, a degraded silt loam. And in this case, the soil was only able to hold about 93 units of N. Now, if you wanted your grass to sit at a crude protein between 18 and 20%, it would have a plant nitrogen of about 3%. So having a landscape that only held 93 kgs of N in the soil organic matter and released throughout the calendar year is actually only capable of growing 3.1 tonne of dry matter. It's all 93 kgs of N in your natural landscape can grow in a calendar year. I don't know whether you noticed the detail, I really don't want to get into detail, but this trial also applied 190 units of N within the calendar year, and that was done because it's a cut and carry trial. It's like we're having multiple silage crops coming off it. And we wanted to use 190 because it's a figure that's a limitation in New Zealand for the sealing use, and we wanted to use nitrogen because in a cut and carry system, in a low nitrogen world, if you don't put nitrogen on, the clovers will kill your grass because they have all the advantages and they grow back so strongly. And when they grow back on a horizontal leaf plane and your grass is trying to recover in a low nitrogen environment, they can literally smother out your grass over time. So it's a big deal when you're needing to put nitrogen on to actually make your grass competitive. So 190 units of N has grown us another 6 tonne of dry matter. And yet I've shown you those 4 lines that have got different totals. And in a steady state after 12 months, this is what that looks like. So the top clover creating pasture growth was adding another, I can't see it here, but another about 6 tonne of dry matter. And as you can see, each of those clovers was cycling or growing different levels of clover right down to your nitrogen-fed grass and what it was limiting you to. It's a pretty powerful message that if you improve something, you do have to value the fact that that nitrogen cycle, you're enhancing a nitrogen cycle, and you really, really want to get as much out of that cycle to make those dollars work. That all that evidence was showing with Steve and Jason in their analysis. I think a statement I quite often use is the devil's in the detail. You can spend the same amount of money and get that result, same amount of nutrient or soil improvement to get that result, when for a small upfront cost and value and getting the right choice of legume, you could get a much bigger result. And again, I'm not talking white clover here, I'm just talking about valuing the performance of individual clover genetics. It's worth valuing because it's adding so much more to your system. I don't really need to talk too much about these, but I'm going to keep the context to diverse pastures and understanding how all these plants may bring baggage to those relationships. So I'm looking at lucerne here, really inside a perennial pasture. Because for the scale of it, it's only one of the few plants that can actually tolerate the longevity of some of the expectations of some of the perenniality you've got. It's got real limitations around different soils though. So it's surprisingly good in relationships, and I would suggest to you, on average, the most difficult place to put lucerne in a grass pasture is in a stressed season like we're discussing now, and even half of what you've got now. Putting lucerne in a pasture would be extremely tough for its survival. Because in a pure stand, you can still value it and manage it. Once you decide it's my legume of choice in a perennial pasture, because it complements the time frame I might expect my perennial pasture to last, you suddenly realise that actually I'm not putting it in to manage it like it deserves. I'm putting it in because maybe, just maybe, it can tolerate it. It may never grow as much, but it may survive. And that's the context to sometimes how I look at lucerne, is if I'm trying to pair it with something, I'm looking at how long is my expectation, how good is my soil, how fertile is my landscape, and can I get it established to start with, because it still takes quite a bit of time with a good lucerne to actually graze it out. I think this year you might have achieved that if you put it in a pasture, to be fair. Red clover, I think this one's an interesting one in my eyes, because red says it all for parts of Victoria that I've experienced, is that if you don't have red soils, it's probably not red clover country. So everywhere I've seen it perform really well, it's the spud country, and it fits very, very well into some of those fertile red soils. Fits very, very well in some of those faster rotations. Has a really nice fit with prairie grass, really nice fit with chicory. Where you're getting performance over time out of those types of species, red clover is actually an interesting plant in that situation. So, yep, traditional, surprisingly good in relationships. Any sort of high performance mix, but as I would suggest, as I said, it really has gone particularly well in that red spud zone. Now, this is a couple of plants that I've spent a long time working with, and they do have a place, and they are part of the diverse discussion, and they are a big part of maintaining some elements inside more perennial pastures. Chicory is quite a vulnerable plant to the wrong soil types. You've got a beautiful dynamic and a real, in a whatever an average year looks like. You've got red gum flats, which by definition means you're quite wet for moments, particularly late winter and spring. Obviously, again, not this year. But the point is that's not a great time for survival for chicory. It does like free draining soils. So the more balanced the soil, the longer chicory can survive in your landscape. And you've got some wonderful data on longevity of chicory in New Zealand, particularly from Sarah O's out of New South Wales. There's a really strong paper about just how well they last under some pretty decent dry conditions around Wagga and all through southern New South Wales. So chicories are really good in a lot of relationships. The thing about chicory though, you do often get surprised by how many weeds you can have in your landscape when you work out you can't spray the weeds out. So it's like a booby trap plant, basically. Ideally, the world's changing. I got parasite resistance coming at me like a freight train. I want to find nutritious, high value, high protein, high ME plants to sort of complement other stresses in my business. And next thing you know, you put it in paddocks just covered in weeds. And that has lasted in my career forever. So the thing about chicory in your landscape, when you want to take advantages of it and you want to put it into your production system or into your pastures, you do have to think about how you're cleaning your landscape, and you do have to know your backgrounds of some of those paddocks. I would describe as many of your paddocks tend to be booby traps because the weed seed is a little bit deeper than the top sometimes. So sometimes you just don't know what you're digging up. But the last thing you want to do is go into thistle country with chicory. Plantain, another plant with baggage actually, something that I brought to Australia in the 90s. Super interesting plant from one perspective. Probably until 2007, 2008, we literally only put it in pasture mixes. We went through a phase between 2009 and 2015 where we identified that all the live weight work in New Zealand over the years on lambs have been only done in summertime, like literally only in summer. There is no live weight in winter in literature, no live weight in spring anywhere, and we're a spring lambing system on average. And so what we identified with plantain, and it still exists and still performs in this role today, is that as a sheep and ewe lactation feed, it's exceptional. It is better than other things. With this plant, the baggage that has occurred since then is that your farm business is beyond just your lactation phase. It is not just your lambing feed, and it's not just your early weaning feed. It's got to do other things as well. And then it's got to last. And initially, I'd be part of this process because we're all learning, unfortunately, is that, the hope was that it was going to be a really perennial species. And that bias has stuck with this plant for a long time since we fully acknowledge that it's a 2 to 3 year type species, no different to the prairie grass and no different to any other species that just doesn't last. The other thing we learned about this species is it's doing weird stuff in the soil. In the first year, it's incredibly strong at growing with not a lot of nutrient. In the second year, it starts tying up a lot of nutrient for itself particularly, which basically means it can grow a lot with a very little in this first calendar year, but once it goes into its second year and goes into a seeding cycle, it's tying up so much nitrogen in the soil, we're getting a nitrogen-deprived state, creating palatability, underperformance, leaf diseases, and actually the last part of its system is what has created the biggest bias against plantain. Interestingly enough, there's a lot of money still to be made in your production systems off lambing onto winter active plantain and weaning onto winter active plantain in spring. However, when you invest in a shorter term crop, recognising it's not going to last forever, you have to maximise that advantage. So you're putting first lambing ewes, young ewes lambing with twin-bearing lambs on it. You're putting last cull for age twin-bearing ewes on it. You're not putting singles on it. Everything we identified about this plant is lambs start eating it at about 21 days. It's hugely more preferred by lambs than virtually any other plant we've gone near. So for that window of time, it absolutely and utterly works. But we've now created so much baggage about this plant that it's been put aside. Super interesting. We've discovered so much through this process about it. But the last thing, and the biggest thing that I feel with this plant, is we should have systemised it from day one, and we should have said it was only going to last for 18 months. Because all the baggage starts from that point onwards. Get 2 lambings out of it, and blow it out the following spring. Would be my greatest example of how you would reimagine how you would use that plant. So just to finish off, we've got a project that your group has visited. Visited this beef unit in Marshdale in North Canterbury. It sits at about 280 metres above sea level. It will have snow on it as of now. So we've just had another snow front gone through, and we've literally had snow to sea level on the north side of Christchurch, which is really a tough landscape actually to get snow at this time of year. So what we've got here is a 65 hectare beef unit where, as my colleague and friend would say, it's where the rubber hits the road, where it all becomes real for us. So we buy, we own, we trade, and we lose or make money off stock on this property. And so this is where we practice a little bit about what we preach, and also we start projects that might be focused on just discovering how things might work. And one of the projects that this property has been instigating has been a diverse pasture trial, which would have started probably about a year after the regenerative ag focus kicked in, and the broader topics of pasture diversity really kicked off. It's a pretty interesting moment because there's a lot of passion around some of these topics, and I put it here because I think it sort of ties up putting plants together. We just sort of discussed some of the positive traits of all these things you already know, and then when you come to use them, you try to design pastures, and probably for the last 6 to 7 years, you probably had a lot of interest in probably working out, like, how can I add more diversity to my landscape? And we have been discussing all the problems with that because not everything likes each other and not everything works well together. So what we're looking at here is the way this trial was laid out was in 3 hectare blocks broken into 10 cells, and the trials were sown down into a group of pastures, and now we're into the 4th year, heading for our 5th year of information generated. I don't want you to dwell on too much on this slide other than to look at a couple of the highlights at the top. We have 2 relatively lax systems, and the biggest point about the regenerative element of the Diverse Pasture Project is that people had a philosophy at this time of plants circulating nutrient, and that you must leave material on the surface to enhance the microbial interaction and release a lot more nutrients from your soil. So basically using plants to cycle nutrient, not just through the animal, which is the highest level principle of what most of us practice. We've discussed some real macro moments today, and I think the bigger point I would always make is be aware that the macro parts of all these discussions are what drives your business. So soil microbial activity is such a big driver of spring and autumn production. pH is such a big driver of soil health and soil productivity. pH management, driving legume production and creating nitrogen cycles is such a big part of a healthy soil landscape. So once you pull all these things together, it's a really big deal to understand that actually most of the time getting the macro things right are more important than leaving some material behind to feed the bugs or cycle nutrient through plants. You can cycle nutrient because of root structure breakdown because you're growing more, and also cycling them through animals. And to a great degree, this is what this work's highlighted. So we created 2 lax treatments. Those lax treatments were 40-day rotations. We made a call not to eat all we grew with cattle. So the rotations are 40 days long, and we're leaving half of what we grew behind, and we're 4 years deep into that practice. There's some real interesting trends here to what you've already been discussing with Steve. I wanted to fast forward because I had a pretty strong indication. Oh, by the way, there were 28 species in that complex mix initially. I wanted to fast forward that whole project because sometimes people say, but we're talking about perenniality and the end of 5 years, it's not perennial. It's about, the magic's about to start. So what we did is we picked a stand of cocksfoot, red clover and lucerne, plants that actually have worked in this environment with cocksfoot under beef grazing. And we started that, and it was already 5 years old. So that's approaching 8 to 9 years old. So if anything was going to happen in the soil, this is an untouched grassland for 8 to 9 years being farmed in a lax way. We've got a native pasture, which is actually a really interesting treatment because there's not too many landscapes like this that would have a pasture with a soil that's untouched for 50 years. There's been no seed added to this landscape and no soil moderation. We've just applied 2 major principles. We add capital nutrient. This treatment is intensive, so it's old pasture and it's intensive. It's on a 30-day rotation, and we apply the same nutrient return and the same nitrogen as our improved pastures. The 2 other improved pastures are a new tall fescue pasture, it's now 4 years old, and a new ryegrass and cocksfoot pasture. They all have about 6 to 7 species in them. They're the usual suspects: white clover, red clover, chicory, and plantain. So this is how some of our more diverse pastures started. There's a whole perennial pasture under that. That's how it transitioned. That's what I predicted it was going to look like. And that's the 6-year-old advanced aged version of this. That's your 50-year-old pasture that actually is relatively normal. A new fescue pasture being a friend to its other relationships. Ryegrass pasture. This is what's happening in the ecological state of these paddocks over time. So what we can see is that grass is fulfilling its place and heading towards a high proportion in the diverse pastures. And this is the point. We can make it too lax, and the issue with lax grazing and leaving high covers is actually not all plants like that. They'll smother each other out. They'll fight each other. And in this case, lax cocksfoot has dominated. And so within about 1.5 years from 28 species, you would be blown away how fast our management interaction has driven the 28 species to look like my 6 or 7-year-old cocksfoot stand. And the only plants that liked the management were chicory, red clover, and lucerne. Lax beef grazing with cocksfoot. Really predictable. This was an interesting one because this has been the most profitable and productive pasture so far. And as I've said to you, on average, fescue is a good partner. But actually, a bit like the pH discussion, a bit like the productivity discussion, we have captured a lot of it in meat, but the reality is the fescue is strong. And so the ecological state of what we've created and how we're managing it on a 30-day rotation has seen our clover content decline, our herb content's gone out. Unfortunately, we used a herbicide that knocked out the plantain from day one. I was pretty unhappy about that, actually. But that's the way it happened. Like I say, when you get weeds, you make decisions. So you've got to think about what's there to start with. But that's how it looks now. And this is what it looks like in economic terms in year 2 or year 3 and the end of year 4. So this is the end of year 3. What we're seeing is average daily live weight. This is the live weight measured starting in the spring with R2s, quite heavy animals, moving on to R1s throughout the rest of the year once they go to market in the spring. This is the average live weight today. This is the cumulative live weight per hectare. And we've got incomes that don't relate to yourselves, but the point is the relativity of what we're harvesting is important. So most important thing, we're leaving so much feed behind when we decide not to eat it, yet you don't carry the stocking rate. And this is about that optimal stocking rate and curve that Steve put up there earlier. And it's so powerful because this is exactly what's going on. We're at a really luxury component of the curve. We're leaving so much feed behind, we're going nowhere near close to your economic potential. And if we ate more, we'd also change the diversity of what was there. Other things would actually survive because we were eating more of what was there. But the decision was made to how we'd run it from day one. You can see the answers are just coming from the fact that we don't have the animals. The live weight gain, even when you're just skimming the top, is on average still no better than the high performance pastures or even the native pasture. In the 4th year, you can see the trends have continued. And I think this part of the presentation is a really nice way to highlight the outcomes of this bit of work. Because it's not just about one financial year, it is about what it's adding up over time. And so what we can see here is the first 3 lines are solely being created by our implementation of a stocking rate decision. We decided on eating more of our grass, and we focused on grass eaten, not deferred or leaving high covers. So the vast amount of this outcome has solely been on the back of our management decisions. This is a 50-year-old pasture with outstanding carbon content, outstanding organic matter. It's a really big point to make here. That amazing carbon content and amazing organic matter, which is pretty impressive. We talk in organic matter more than carbon. I've been meaning to convert that to make it clearer. But the organic matters here, after 50 years, are about 12%, which is amazing. But can I ask you, moving from live weight to economics, having that organic matter and carbon in the ground made it a more profitable pasture? Because actually it's all tied up in a thatch. It's got bent grass. It's 50 years old. It's got species that don't grow in the spring and don't grow in the autumn. That dollar value that 50-year-old pasture has created has had the same amount of phosphate and the same amount of nitrogen as the two lines above it. So it's a really interesting thing. This project was focused on the value of all things, animals, plants, and soil. And one of the things that I can't help but emphasise is for us as graziers, people looking after pH, you're running healthy, profitable businesses on average in a good year, whatever a good year looks like. But the point is, you are trying to do the best for the land as graziers. You're not monoculture cropping landscape in this group. You are trying to make the landscape healthier. And the big point is you can only take that so far because you can't actually dig it up and sell it. You still want to use that organic matter, you want to use that carbon and capture it by mineralising it. Yes, it will drop down, but then you'll spend the next 10 years in a perennial pasture system building it back up. And in New Zealand, that's what we do a lot. We actually see the organic matter in our soil and the carbon in our soil as an opportunity to release nutrients, grow healthy crops, and then go back into a long-term grazing system and regenerate that soil through rotational grazing. But what I can tell you, it takes a bloody long time. We've just had the 4th year of organic matters, and in these pastures here that have gone through cropping systems, they have still not started to move, even though they're carrying stock and building up. So it takes a long time to get it back. But we're talking figures of 8% organic matters and 9% organic matters. They are brilliant by world standards. They are not a West Australian wheat crop. We are running grazing systems. Very, very important. So quickly in summary, nature is driving for an ecological balance in your pastures. Our day jobs is to try and manipulate that amount as much as we can to create productive plant species in your pastures to fit your production systems for as long as possible. And at heart, that is the biggest day job we all have when we sit around a table and think about your lambing dates, your other production systems that may fit inside your business, because actually knowing a little bit about the detail of the growth curves of your plants, matching them to your farm systems, is literally one of the things that we would be part of your team around your table. So I can't emphasise enough that whole creating a team that is meeting your expectations, listening to what your business ideals are. I look at understanding plants and actually recognising that the decisions you make about putting plants together, putting plants in different landscapes, to benefit your production system, the devil really sits in the detail. So that will be where I'll finish on that one. I can't emphasise enough, you know so much of this. You're a group that is doing super well in this space in a very stressful time frame. The point I would also make is, and one of the messages I will continue to give, is you've already heard it, but you're running businesses that are pretty consistent. The same thing's happening on average every year. The best thing you can do when you commit to spending any money is get your timing right. Don't get late. Don't go too early. Work out what is the sweet spot for doing what you need to do, and actually once you commit to that spend, do it in a timely manner. The biggest thing that you can depreciate your input costs is by growing more. It's the only thing that works. So delaying anything through decision making or whatever, once you commit, get your timing right. And I know the climatic conditions will always impact exactly what you're doing, But be aware that once you commit to a spend inside creating pastures or crops, there's nothing more important than your day job because you're committed to the cost. And the only way the cost gets depreciated is by getting it right at the start. It's the best chance you have of actually getting the best result and getting the return on that investment. So once the decisions are made, just focus on getting that day job right, and that's where your agronomists come in, and they'll support you on that thing. Get your contractors or get your business right, and recognise at times once you commit to a process, there's actually at that moment not a lot more important than getting your timing right because you're already committed to the cost structure. That would probably be the final part of that messaging when it comes to plants. Timing is king of getting things started. Everything else creates stress and actually underwhelming performance. And weather will play a part in that, but if you're not in, you can't have a win. And if you're not in and other things go wrong, like parasite resistance and other things, and you don't have pivot points, it's quite a big deal as well. Thank you.